America's deadliest sniper rifle was never meant for war. It was fragile. It fogged. It failed in humidity. In the jungle, it broke down faster than doctrine could explain. Military evaluators rejected it for all the right reasons. And yet, in the right place, under the right conditions, it turned impossible shots into routine kills. That contradiction is where this story begins. In the opening phase of the Pacific War, American forces encountered a problem they were not trained to name. They were not being defeated by superior tactics. They were not outmatched in courage or discipline. They were being defeated by distance. Combat no longer unfolded at ranges where training and equipment overlapped. Engagements stretched outward, beyond familiar limits, into spaces where the enemy could act freely while Americans struggled to respond. Fire came from ridgelines, aircraft, and concealed positions that lay just far enough away to remain untouchable. Marines could hear shots. They could sense movement, but they could not reliably see. This was not a failure of the soldier. It was a failure of vision. American marksmanship doctrine had been built on certainty, known distances, clearly defined targets, equipment designed to survive abuse rather than deliver extreme precision. On ranges, this philosophy worked perfectly. On battlefields, shaped by smoke, heat, and movement, it collapsed. Through standard military optics, distant targets dissolved into blur. Contrast vanished. Depth became guesswork. Aiming beyond medium range felt less like marksmanship and more like probability. Every trigger pull carried doubt, and doubt, in combat, is paralyzing. What made the situation worse was that the enemy understood this gap. Japanese forces exploited distance deliberately, positioning themselves just beyond effective American reach. They were not invisible, they were simply unreachable. The battlefield became asymmetrical not because of numbers, but because of perception. Distance became a shield, and whoever controlled distance controlled the fight. Inside American units, this created a quiet psychological fracture. Soldiers are trained to trust their tools. Equipment is not just gear, it is an extension of confidence. When it fails silently, trust erodes. Men begin to hesitate. They second-guess shots. They feel hunted rather than empowered. The jungle amplified this imbalance. Heat distorted sight lines. Smoke lingered. Humidity crept into every mechanism. Even when a target revealed itself for a moment, clarity rarely lasted long enough to act decisively. The battlefield felt hostile, not just because of the enemy, but because of the environment itself. This forced an uncomfortable realization. American forces were not losing because they lacked skill. They were losing because their equipment no longer matched reality. That realization challenged something deeper than hardware. It challenged doctrine. Military systems are built on reliability. Equipment must survive neglect, stress, and misuse. Anything fragile is treated as dangerous. Anything complex is viewed as a liability. Precision, when it comes at the cost of durability, is often dismissed as impractical. And yet, precision was exactly what the battlefield now demanded. Somewhere far from the Pacific, outside military supply chains and doctrine manuals, there already existed tools capable of reaching across these distances. Civilian optics designed not for survival, but for clarity. Instruments built to deliver extreme precision under controlled conditions. Tools that could turn blur into certainty. The problem was obvious. These tools were never meant for war. They required care. They demanded maintenance. They punished neglect. Everything about them violated military instinct. To a procurement officer, they looked like a liability waiting to happen. To a soldier in the jungle, they looked like something that would fail at the worst possible moment. The verdict, on paper, was easy. Reject them. Civilian equipment had no place on the battlefield. War was not a laboratory. Precision meant nothing if it could not survive mud, rain, and exhaustion. Better to accept shorter range than gamble on a system that might collapse under stress. That logic was sound. It was also incomplete. Because war does not punish fragility alone. It punishes blindness. Casualties mounted, reports from the field began to converge on the same pattern. Whenever American forces could identify targets clearly, they dominated. Whenever they could not, they bled. The issue was no longer abstract. It was measurable, repeatable, lethal. The question shifted. Not, is this equipment perfect? Well, one go away. But is refusing it costing more lives than accepting its risks? And this was not a technological debate. It was a moral one. How many failures were acceptable to prevent how many deaths? At what point does playing it safe become the most dangerous option? The military did not suddenly abandon its principles. It hesitated. It resisted. It argued. But war has a way of reopening decisions that doctrine tries to close. Somewhere between caution and desperation, a line was crossed. The battlefield was no longer asking for equipment that worked everywhere. It was demanding equipment that worked where it mattered most. And that demand would pull a fragile civilian invention into the heart of modern warfare. Not as a miracle, not as a universal solution, but as a dangerous experiment that would fail in one environment, succeed in another, and permanently change how the United States thought about distance, precision, and risk. The rifle was never meant for war, but war was about to decide whether that mattered. The problem wasn't bravery. It wasn't discipline. And it wasn't skill. It was distance. Across the early battles of the Pacific, American Marines discovered a reality no training manual had prepared them for. They could hit what they could see, but modern combat was happening far beyond what they were able to see clearly. Enemy gunners fired from ridgelines, pilots strafed from the air, and snipers operated from positions that lay just outside effective American reach. The shots came in, the return fire didn't. On paper, American rifles were excellent weapons. They had proven themselves on competition ranges and qualification fields for decades. Marines trained relentlessly, memorizing distances, wind calls, breathing cycles. Under controlled conditions, they performed with near-mechanical precision. But the battlefield shredded those assumptions within minutes. Smoke blurred the horizon. Heat distorted the air. Targets moved, vanished, reappeared. And beyond a certain range, everything dissolved into vague shapes and shadows. This created a deadly imbalance. Not because the enemy was better trained, but because they were operating in a space Americans could not control. A no-man's land measured not in yards on a map, but in visibility. A silent killing zone where American troops could be targeted without the ability to respond effectively. Each after-action report carried the same undertone. Marines weren't losing fights because they missed easy shots. They were losing fights because they never truly saw the enemy in the first place. Rifles barked. Bullets flew. But at long range, those shots were educated guesses at best. The uncomfortable truth began to take shape. American marksmanship doctrine had been built for a different kind of war. For decades, training emphasized known distances, clear targets, and predictable conditions. That approach worked beautifully on ranges and failed brutally in jungles, beaches, and shattered ports. The equipment had been designed to survive rough handling, not to dominate extreme distance. Reliability had been prioritized over reach, simplicity over precision. And now Marines were paying for that trade-off in blood. Within the Marine Corps, this realization created quiet tension. The shooters were doing everything right. The rifles were functioning as intended. And yet, something fundamental was missing. The enemy could see first, fire first, kill first. If the rifle was the soldier's only connection to the battlefield, then vision had become the weakest link in the chain. Some officers began asking questions no one liked to hear. What if the standard scope wasn't good enough anymore? What if durability had been overvalued and clarity undervalued? What if the battlefield itself had outgrown the tools meant to fight on it? These questions collided head-on with military culture. Armies are built on standardization, on proven systems, on equipment that works for everyone, not equipment that works perfectly for a few. Fragile mechanisms were distrusted. Civilian designs were dismissed. Anything that required extra care, extra training, or extra explanation was seen as a liability. Because in war, complexity kills, or so the logic went. Yet reports kept piling up. Again and again, the same pattern emerged. When Marines could identify targets at long range, they won. When they couldn't, they bled. The issue wasn't courage under fire. It was vision under pressure. That gap between what Marines could do and what their equipment allowed them to do became impossible to ignore. And that gap pointed to a dangerous idea. Somewhere outside military doctrine, outside procurement pipelines, outside standardized thinking, there already existed a solution. Not one built for mud or rain or neglect, but one built for precision. Extreme precision. The kind of precision that could reach across distances once considered untouchable. The problem was simple. The military had already rejected it. Civilian optics were not meant for combat. They were considered too delicate, too complex, too maintenance-heavy. They belonged on clean ranges, not battlefields soaked in salt water and humidity. To most evaluators, the verdict was obvious. These tools might see farther, but they wouldn't survive long enough to matter. But desperation changes the math. When casualties mount, rules bend. When doctrine fails, alternatives suddenly look less foolish. And when enough Marines die beyond effective range, the definition of acceptable risk shifts. The Marine Corps didn't go looking for a miracle. It went looking for an edge. And that search would lead not to a weapons factory or an arsenal, but to a small civilian workshop run by a man whose designs had never been meant for war and whose ideas directly challenged everything the military believed about reliability, simplicity, and combat equipment. The impossible idea was no longer whether his invention could work, it was whether the battlefield could tolerate it. The workshop didn't look like a place where military history would change. It wasn't guarded, it wasn't classified, and it certainly wasn't built for war. Tucked away far from any battlefield, it smelled of oil, metal, and ground glass, the quiet rhythm of civilian craftsmanship. This was where precision lived, not survival. Inside worked a gunsmith and optical designer who thought in fractions, not doctrines. His scopes weren't built to be thrown, soaked, or ignored. They were built to be adjusted, tuned, protected. They demanded care, and in return, they delivered something the military didn't have: clarity. When Marine evaluators first looked through the scope, the reaction was immediate and unsettling. Targets that had once dissolved into haze snapped into focus. Shapes became people. Distance collapsed. What had been guesswork turned into certainty. At ranges where standard military optics failed, this civilian scope still worked calmly, almost arrogantly. It didn't promise toughness, it promised vision. And that was the problem. Military doctrine had been shaped by hard lessons. Equipment had to survive abuse by exhausted soldiers under fire. Anything that required careful handling was treated as a liability. Simpler was safer, rugged beat refined. This scope violated all of that. It had external adjustment knobs, precise, exposed mechanisms that allowed shooters to dial exact elevation and windage instead of holding over and guessing. That precision was revolutionary. It was also terrifying to anyone responsible for keeping thousands of rifles functioning in combat. More moving parts meant more things to break. More maintenance meant more failure points. More training meant more room for mistakes. On paper, the verdict was already written. But war doesn't live on paper. The Marine Corps faced a contradiction it couldn't ignore. The scope worked undeniably so. Test results showed tighter groups, longer effective range, and first-round hits at distances previously considered unreachable. In controlled conditions, it outperformed everything in service. Yet every strength came with a warning attached. Humidity could seize the mechanisms, dust could jam the adjustments, recoil could shift the mount if improperly secured. It wasn't forgiving. It demanded discipline. For the first time, the military wasn't choosing between good and bad equipment. It was choosing between certainty and potential. Some officers pushed back hard. Argued that war punished fragility, that perfect accuracy meant nothing if the scope failed at the worst moment. They had seen too many miracle systems crumble under real conditions. Others saw something different. They saw a tool that could change the geometry of the battlefield, a way to reach across the killing zone that had been costing lives, a chance to take control of distance itself. The debate split along a familiar line: reliability versus performance, uniformity versus specialization, the average soldier versus the exceptional one. In the end, desperation tipped the scale. The Marine Corps didn't fully embrace the idea. It compromised. The scope wouldn't be issued widely. It wouldn't replace standard equipment. Instead, it would be given to a small number of carefully selected shooters, men with proven discipline, patience, and technical aptitude. Snipers. The logic was simple. If anyone could keep this fragile system alive in combat, it would be them. The first rifles were assembled with almost obsessive care. Precision barrels, carefully fitted mounts, each scope aligned, tested, and retested. Maintenance manuals grew thicker than some field guides. Soldiers were taught not just how to shoot, but how to protect the instrument that made the shot possible. Early reports were intoxicating. In the right hands, under the right conditions, the system was devastating. Engagement distances stretched outward. Enemy positions once considered safe were suddenly vulnerable. Shots landed where none should have. But war had not finished asking its questions. When the rifles moved from test ranges to real battlefields, the environment began to push back. Rain seeped into mechanisms. Salt air corroded metal. Fine dust crept into every exposed surface. The same precision that made the scope deadly also made it unforgiving. Some snipers adapted. They babied the equipment, protected it like a living thing, cleaned it obsessively. Others struggled. A single failure at the wrong moment erased every advantage. Field reports became contradictory. One unit described remarkable success. Another called the system unusable. The same rifle that dominated one engagement failed completely in the next. The impossible idea had crossed into reality, but reality was messy. The military now faced a second, far more dangerous question. Was this system a breakthrough or a mistake that only looked good under perfect conditions? The answer would not come from engineers or procurement boards. It would come from the battlefield itself, where the environment would decide whether precision could survive chaos. And that decision was about to be made in the worst place imaginable. The battlefield answered without mercy. The moment the sniper rifles left controlled environments and entered the Pacific, everything that had looked manageable on paper began to unravel. Heat pressed down without relief. Humidity soaked into metal, wood, and cloth. Salt air clung to every surface. Fine coral dust worked its way into mechanisms, no matter how carefully they were sealed. This was the environment the scopes had never been designed for. At first, the results were confusing. In dry conditions or short engagements, the rifles performed exactly as promised. Snipers reported hits at distances that would have been unthinkable months earlier. Enemy positions, once considered untouchable, were neutralized with single shots. Confidence surged. The impossible idea appeared to be working. Then the failures began. Adjustment knobs stiffened, then froze. Moisture condensed inside the optics, fogging lenses at the worst possible moment. Mounts that held steady during training loosened under sustained recoil. Zero drifted. Precision vanished. The problem wasn't that the system never worked. The problem was that it didn't always work. And in combat, sometimes is another word for death. After-action reports arrived in waves. One unit praised the system as a game-changer. Another condemned it as unusable. Snipers described wildly different experiences depending on terrain, weather, and maintenance discipline. The same rifle that dominated one island failed completely on the next. Commanders were forced into impossible decisions: keep issuing equipment that could deliver extraordinary results, or pull it before it failed someone at the wrong moment. The logic of war favors certainty. A mediocre weapon that always works is safer than a perfect weapon that only works under ideal conditions. Nowhere was this dilemma more visible than in jungle combat. The Pacific Theater punished precision. Rain fell without warning. Heat cycles caused metal to expand and contract. Mud, sand, and plant debris coated everything. Even disciplined snipers struggled to keep the equipment functional while moving, fighting, and surviving. And when the scope failed, it didn't just reduce effectiveness, it changed behavior. Snipers hesitated. They second-guessed shots. They lost confidence in the very tool meant to give them dominance. In a role where patience and trust in equipment are everything, doubt became lethal. One failure could erase weeks of success. Reports grew harsher. Phrases like too fragile, maintenance-intensive, and unsuitable for sustained combat operations appeared again and again. The same arguments raised during early evaluations resurfaced now, backed by blood and experience. The institutional response was predictable. Officers who had opposed the system felt vindicated. They argued that the battlefield had proven their point. War was not a laboratory. Civilian precision had no place in mud and chaos. Complexity had betrayed those who trusted it. Slowly, quietly, the decision formed. The sniper rifles would be phased out, not because they were ineffective, but because they were unreliable. The Marine Corps began reverting to simpler, tougher systems with shorter, effective range, but fewer points of failure. The killing zone expanded again. Distance was surrendered in exchange for certainty. For many snipers, the reversal felt like a step backward. They had seen what was possible. They had tasted dominance over terrain and distance. Now they were being asked to give it up, not because it didn't work, but because it worked only when conditions allowed. The impossible idea had run into an unmovable wall: environment. But the story didn't end with rejection, because war doesn't just destroy ideas, it refines them. Even as official policy turned away from the system, individual Marines began adapting. They improvised protective covers. They modified maintenance routines. They learned when to deploy the scopes and when not to. Field solutions emerged faster than doctrine ever could. Some snipers treated the equipment like a fragile ally rather than a rugged tool. They protected it obsessively, and when conditions aligned, they achieved results that no standard rifle could match. These isolated successes posed a dangerous question. What if the system wasn't fundamentally flawed? What if it had simply been used in the wrong environment? That question wouldn't be answered in the Pacific. It would be answered years later, on a different peninsula, under a different sky, where humidity retreated, distances stretched, and the battlefield finally matched the design assumptions behind the impossible idea. The rifle had failed its first war, but it had not exhausted its potential, and history was about to give it a second chance. The rifle didn't change. The war did. When the next conflict began, the equipment everyone had written off was pulled from storage out of necessity, not belief. There was no grand rehabilitation, no apology, just a shortage of options and a quiet decision to issue whatever was available. This time, the battlefield was different. Gone were the steaming jungles and salt-soaked islands. In their place stood dry air, long sight lines, open valleys, and mountains that stretched engagement distances beyond anything the previous war had allowed. Visibility wasn't the exception anymore. It was the rule. And suddenly, the fragile system stopped failing. In this environment, the scope behaved exactly as its designer had intended. External adjustments turned smoothly. Lenses stayed clear. Mounts held zero. Precision returned, not occasionally, but consistently. What had once been a liability became an advantage. For snipers trained to exploit distance, the effect was immediate. Targets that would have required multiple ranging shots with simpler optics now fell with the first round. Enemy positions believed to be safely out of reach were no longer protected by terrain alone. The geometry of the battlefield shifted again, but this time, it shifted decisively. Reports told a different story than before. Engagements at extreme range became routine. First-round hit rates climbed. Confidence returned not just in the shooter, but in the system itself. The same rifle that had been cursed in one war was suddenly redefining what long range meant in another. This wasn't redemption through redesign. It was vindication through context. The equipment hadn't been wrong. The assumptions had been. The earlier failure was never about incompetence or flawed engineering. It was about environment. Moisture, dust, and heat had punished precision. Dry air and clear sight lines rewarded it. Once those variables flipped, so did the outcome. The military took notice, not with celebration, but with documentation. Every successful engagement was recorded. Distances were measured. Hit rates were logged. For the first time, the system's performance matched its theoretical potential, not in a test report, but in combat. The lesson was uncomfortable. It suggested that previous doctrine hadn't failed because it was careless, but because it was incomplete. Reliability and simplicity mattered, but so did specialization. A weapon didn't have to work everywhere to be valuable. It had to work where it mattered most. This realization reshaped sniper thinking. Training shifted from one-system-fits-all toward matching equipment to environment. Maintenance discipline became part of marksmanship. Snipers weren't just shooters anymore. They were custodians of precision. The impossible idea had survived not by becoming tougher, but by being understood. Its legacy wasn't that it became perfect. It was that it forced the military to accept an uncomfortable truth. Technology doesn't win wars by itself. But when environment, doctrine, and human discipline align, even a fragile idea can become deadly. The rifle had failed once, it had succeeded once, and that contradiction would shape how America thought about precision warfare for decades to come. The lesson wasn't about a rifle, it was about reality. The military didn't declare the system a miracle, it didn't crown it flawless. Instead, it quietly absorbed the evidence and moved on changed. The impossible idea never became universal issue, but it left a permanent mark on how precision warfare was understood. Future sniper programs no longer asked a single question, is it rugged? They asked two, where will it be used, and who will use it? Design philosophy shifted. Precision optics would never again be judged in isolation. Environment became a co-designer. Climate, terrain, and maintenance culture were treated as factors just as important as magnification or accuracy. Equipment wasn't just tested, it was stress-tested against reality. The failures mattered as much as the successes. Engineers learned that external adjustments offered unmatched precision, but demanded protection. Militaries learned that giving advanced tools to average users invited failure, but placing them in disciplined hands could redefine the battlefield. Snipers learned that accuracy wasn't just about pulling the trigger, but about caring for the instrument that made the shot possible. The system's contradictions became doctrine. Later generations of sniper rifles borrowed selectively from the idea. Better sealing, internal adjustments, improved coatings, simplified maintenance. The precision survived, the fragility was engineered out, yet the core lesson remained intact. There is no such thing as universally good equipment. Only equipment matched or mismatched to reality. The rifle that failed in humidity and triumphed in dry air became a case study taught not as triumph, but as warning. Innovation without context is risk. Context without innovation is stagnation. History rarely rewards ideas that are simply right. It rewards ideas that arrive at the right place, at the right time, with the right understanding. The gunsmith didn't create a perfect weapon. He created a question the military could no longer ignore. How far is too far? How fragile is too fragile? And when does accepting risk save more lives than avoiding it? Those questions echo through every modern precision weapon system in use today. The impossible idea didn't win a war. It changed how wars are prepared for. And that is why it still matters.